Now, the final video in this series is a brief conversation about surface area to volume ratio. So what that really is the surface area of the cell. So all of that surface, and I'll look at these as cells, all of the surfaces here around the cell, and how does that compare to the volume within the cell? So if we look at this diagram here, we can see the purple dot there represents an organelle, and then the surface area around it. So we can see here that the surface area, if these are 1 millimeter cubes, the surface area ends up being 6 millimeters squared, and the volume is 1 millimeter cubed. And we can see that the volume, or the cytosol, the space inside but around that organelle, is quite small. So the membrane is close to the organelle. And what that means is substances that are diffusing into the cell or entering the cell and then moving throughout the cytoplasm actually don't have to move very far until they get to an organelle. So that makes processes happen faster. We can see here as the cell gets bigger, that distance increases, and even bigger, it increases. So as a cell gets bigger, the surface area compared to the volume actually decreases. Here we have a large surface area compared to the volume, and here we have a comparatively smaller surface area compared to the volume. And there's an organelle within plant cells that helps plant cells to decrease their volume comparatively to their surface area. So this vacuole, you can see that the fact that this vacuole is in there kind of squishes those organelles. Here are some chloroplasts, squishes those organelles up in closer to the plasma membrane. So what we're essentially doing is decreasing the volume while still having the same surface area, and that increases the surface area to volume ratio. And what that means is substances will be able to move more efficiently across the membrane and throughout the cell. So this idea is about the efficiency of the movement of the substances into the cell and throughout the cell. Here are your student understandings from the subject outline. Again, it's about the exchange of materials across membranes and the factors that are affecting it, in this case, the surface area to volume ratio. This is a summary page. Now, I've forgotten to put that pencil here, but make sure you take a note on this page. So the idea here, I'm going to talk to this diagram down here, can be demonstrated by how we can put together these 1 centimeter cubes. So we can see here that a 1 centimeter cube, if we have 1, 2, 3, 4, 5, 6 faces on this cube, we're going to have a surface area of 6 centimeters squared. And we know that the volume of a cube is the length times the width, or the height, times the depth. So we've got 1 times 1 times 1 is going to give us the volume. So 1 times 1 times 1 is 1 centimeter cubed. So the overall surface area to volume ratio is 6, the number of faces, to 1. So the surface area is 6 times that of the volume. As we get bigger, we can see that those numbers change. Our surface area here now is 2 times 2 for the area of that face, which is 4. And then when we multiply that by 6 for the 6 faces, we end up with 24 centimeters squared. Now, if we calculate the volume, it's 2 times 2, which is 4, times 2, which is 8. So our volume is 8 centimeters cubed. So our surface area to volume ratio is 3 to 1, because the surface area is 3 times that of the volume. So now we can see already that there's a significant change in this ratio as we get bigger. And then if we do this one more time, we can see that we have an area here of 3 times 3, which is 9 for each face. Ends up being 9 times 6, and we get 54 centimeters squared. Our volume is 3 times 3 times 3. So 3 times 3 is 9, and then times that by 3 again, and we end up with 27. So now our surface area area is only twice as big as our volume, rather than if we went right back here to our smallest cell, 6 times bigger. So here, our surface area to volume ratio is 2 to 1. So this is really important. In these smaller cells, the movement of those substances is going to be much more efficient than the movement of substances into and around these bigger cells here. This part over here just tells you how to calculate it, and that's what I've just gone through for you there.